Hey, hello, and welcome back, everyone. And today we are going to solve this daily challenge from LeetCode, longest arithmetic subsequence of given difference. So we are given an array and an integer difference, and we need to return the length of the longest subsequence in the array whose adjacent elements have a difference equal to the given difference. So what's a subsequence? A subsequence is a sequence derived from the array by deleting some or no elements, and we need to take care that we do not change the order of the remaining elements. So suppose 1 2 3 4 is a subsequence of this array. 1 3 4 is also a subsequence, 1 4 is also a subsequence, and similarly a 1 can also be a subsequence. So what we need to take care is the difference between the two adjacent elements should be equal to the difference given, and we need to find the longest subsequence satisfying this criteria. So whenever we think of a subsequence, we start thinking in the way of dynamic programming. So there can be a recursive approach where we either pick an element or we do not pick an element, and then pass the call the function again repeatedly. So this is mostly done when we are constructing some subsequence. So however, it can give DLE in this case. So what we actually need to do here is make use of hash table. So this hash table will be used to store the length of the longest subsequence for a given number. So each time we go to a number, we'll find a number which is this times less than the given number, and see if that is present in our hash table. And if it is present, we will add the length of the subsequence that is stored in that for that number with 1, because we are also taking the number itself. So for example, first I'll declare this map, the hash table that we need to store. Next we'll start to iterating in the given array. So inside this array, what we need to see is that suppose I'm at 1. So take this as an example. If I'm at 1, so what I will do is I will have to store the length of the longest subsequence that is possible, picking 1, and take keep that in mind that we are considering the numbers that are behind the current index. So the longest length that we can think of would 1 only, by taking the number itself. And what next is we need to check if any if we subtract the difference from the current number, so the answer that we get, if it was present in the map already or not. So what I'm trying to check is if there is a number whose value is equal to x minus the difference given. So what it will do is, suppose now I come to 2. So for 2, I will add 1 for picking itself. Then I will see the difference, like between 2 and minus 1 is equal to 1. So I will check if it was already present in the map. So 1 was present because we had stored in the last iteration. And since the length we stored into the map was 1, so it will get added to the current element, and it will become 2. So what happens if the number is not present in the map? So as you all know that whenever we try to access an element, a key that is non-existent in the map will assign it a default value if we are making use of the square brackets. Next we will need answer that need to be returned. So the max of the answer and length of the subsequence at the current element will decide between these two, and whichever will be the greater will be returned. So we will just return this answer, and before that we also need to declare this answer first. So here, like that. So this code is only about 15 lines, but it is more about understanding and thinking this approach. And let us just check what is the error here. So it's a typo. Let's submit it. So it got accepted, and yes. Now since we can see that the time taken and the memories taken is not very good, so to optimize this code, what we can do here is make this map an unordered one. So it will take lesser time to iterate, because we are not storing anything in sequential way in a map. So yes, it has become a lot faster, about twice, because earlier it was taking some 300 plus milliseconds. Now it is taking 154 seconds. Now to make it even faster, we know that the given problem requires us the numbers that are inside the array are between 10,000 and minus 10,000. So instead of storing them as map, the key of the map, we can make use of an array whose length is um, long enough to accommodate all these numbers that are possible, and we'll make use of them as index. So what I'm trying to say here, instead of the map, I declared a vector whose length was 40,000. So to be safe, I kept it 40,000 instead of 20,000. Then I'm considering 20,000 as my base or the 0 point, and if I add something, it will be in the positive region, and like anything below 20,000 will be the negative 10,000 values that we need to take care of. So just as we were making use of the values as key, here we are making use of them as index, and we are doing the same thing. And increases this improves the runtime and the memory as well. Here you can see it is 97%, and it is 97%, and the memory is also a bit lesser than the earlier one. So that was all. See you tomorrow.